Hi! Today we are going to learn about writing algebraic equations. So our objective is to understand equations in written form, and this is page 42. Now, a few days ago we went over writing expressions, and we looked at a lot of key phrases. Well, we're going to be using some of those same phrases. All right, well, first of all, an algebraic equation is an equation that contains one or more variables and shows that two expressions are equivalent. Here's the key thing right here. It has an equal sign. Okay, so two main defining factors of equations, they have equal signs and they have one solution, at least all the equations we're going to be doing this year. All right, and a solution is a value that is representing the variable and it makes the equation true. So for example, if I look here, 5 is a solution here because if I plug in 5 for n and substitute it in, 5 plus 4 is 9. Now, if I plugged in a different number, let's say 3, if I put in a 3 here, 3 plus 4 is not 9. So 3 is not a solution for n. Okay, so an equation is going to have one solution. Only one number can I actually plug in or substitute in and get 9. So on this section right here, we're going to be substituting in a possible solution for our variable, and then we're going to solve and see if it actually works or not. So we're going to take 5, and we're just going to plug it in for n right there. So that would make 5 plus 6. Well, 5 plus 6 is 11, and this also says 11. Those are the same, so yes, 5 is the solution for n. Let's try this one. Now we have y equals 18, so we're going to take the 18 and we're going to plug it in for y. All right, so 18 minus 6. Well, 18 minus 6 is 12. Well, this says 12, this says 24. Those are not the same value. So this would be no. Okay? And one more. We're going to take this 4 right here and we're going to substitute it in for z. So that means 36 divided by 4. Well, 36 divided by 4 is 9. Well, this says 9 and this says 9. So yes, this is a solution. Okay, so now I have a situation and then I've created an equation to match it. So it says Mark scored 17 points for the home team in a basketball game. His teammates as a group scored P points out of a total of 46 points. Write an equation to represent this problem. Well, first thing I usually do is I look for my different components. We have 17, we have P, and we have 46, and I look and see which one is a total in this situation. So in this case, we have 46 as a total. Then I look and see, okay, is this an addition or subtraction problem, or is it a multiplication or division problem? In this case, I could represent this with addition and subtraction. So because of that, 46 being the total, if I want to make an addition equation, I know that the 46 has to come after the equal sign. That my total is what it is added to, or the sum. Okay? Then that makes my two parts here. So I could add Mark's points and the rest of his team points and get the total. I could also turn this around and say P plus 17 equals 46 because the commutative property. Notice again, my total is at the end. Now, if I want to then reverse that and make it a subtraction problem, I can do that, but in subtraction, we start with the total. So that means 46 would have to start it. I could do 46, then take away the teammates' points and be left with Mark's points of 17. Or I could take 46 and subtract Mark's points and be left with the team's points. So remember, this is called a fact family. So any of these would be acceptable to match this situation. All right, so now we have another situation, and we're going to try to see if we can come up with all the equations that would go with this. So Marie has a fish tank that contains 39 fish. There are 9 goldfish and F other fish. Okay, so first we got to determine, is this an adding and subtracting situation, or is it multiplying and dividing situation? So if I have 39 fish, that's my total, and I have 9 that are goldfish, and then I have these that are the other fish, so I would want to add those to get my total. So this is an addition-subtraction equation. All right, so let's start with the addition ones. I know this is a total, so I know it's going to be equal to 39. So that means I have 9 in F, so 9 plus F. Now the commutative property tells me I can switch those, so f plus 9 also equals 39. Okay, and then for my subtraction equations, I have to start with the total, so now 39 is going to go at the beginning. 39, take away a part, so let's say we take away f, and we'll get the other part of 9. Or we can switch these, 39 minus 9, and we get f. Okay, let's look at our next one. Maya is M years old. Her 10-year-old brother Joe is 3 years younger than Maya. All right, so we've got M for Maya's age, we've got 10, and we've got 3. So first on this one, again, is it addition, subtraction? Is it multiplication, division? If he's 3 years younger, that means I could subtract 3. So that would be an addition, subtraction equation. So let's start with the addition. Okay, I know Maya is older, and M is representing her, so that means this has to be the total in this situation. So equals M. So if I take her younger brother's age and then do the reverse and add 3, then I'll get back to Maya's age. So 10 plus 3, which means I can then reverse that. 3 plus 10 would also equal Maya's age. Okay, and then for subtraction, this is my total, so Maya's age minus 3 would give me her brother's age, which is 10, or Maya's age minus her brother's age would give me a difference of 3 years. Okay, last one. Jamie has 102 beads to make N necklaces. Each necklace will have 17 beads. All right, so this is different because I see some different wording here, and each, this word, that means it could go with multiplication and division, and in this case it does. So I have 102 beads, that's going to be the total, and I'm separating them on to different necklaces, and there's 17 beads on each necklace. All right, so I can start with my total, or I can either end with my total, depends if I want to multiply or divide first. So if I have 102 beads, I could do 102 beads divided by the number of necklaces would give me 17 beads on each necklace. I could also do 102 beads divided by 17 on each necklace would give me N number of necklaces. Okay, now for multiplication, well, I have 17 beads on N necklaces, so I could do 17N equals 102. Notice with multiplication, you end with the total. With division, you start with the total. All right, and then I actually am not going to write another one because technically I know I could do N times 17 and get 102, but in algebraic form, it's proper to put the number in front of the variable as the coefficient. So we're going to leave it like this. So there you go. Here is writing algebraic equations. Remember, equal sign, one solution, and keep practicing.